So what I'm going to talk about, we could have talked about it when we were doing herbicides. So we want to zero in on application of pesticides or simply sprayer calibration. Now on pesticide application, you may find that herbicide rates, or it could be pesticide rates, or dosages, they are in milliliters or liters per hectare. For example, atrazine is a herbicide used to control weeds in maize, and the dosage for sandy soils is 3.5 liters per hectare. Now the question is, how can we possibly apply 3.5 liters per hectare? Even if we give you a bottle of a 5-liter mazo, and we say spread it per hectare, you may find it difficult. So you need the generation of droplets via nozzles. So we can mix the pesticide with water and spray the water via nozzles to create these droplets so that we are able to cover 1 hectare. So our objective is to determine what is known as the amount of water required to spray 1 hectare, which becomes the spray rate. We can use a nozzle, we can use a knapsack sprayer fitted with a nozzle. Here we have got hollow cone nozzles which are suitable for, especially the red one. It is suitable for insecticides, not for herbicides. So this one could be used to spray insects or diseases, fungi. But the flat fan nozzles can be used to apply herbicides. Now these flat fan nozzles have got a tapered edged ends. They produce a funny type pattern like what we have seen previously. And when you are fitting these on a tractor boom sprayer, you need to fit them well, because sometimes you end up under applying the herbicide or over applying it. So you have to do what is known as to do the correction for overlapping, so that you reduce the variation in the herbicide application. I will show you how it's done. This is the flat fan nozzle. Again, the flat fan nozzle spray pattern. And where you have the spray hitting the ground, it forms that shape, and at the end it seems to be pointing, outwards, and the straight line marks where the actual dosage will remain. So it is at those edges that you adjust your nozzles so that there is an overlap at the tapered end, like what has been done here. on a tractor boom sprayer using flat fan spray nozzles. So the nozzles are adjusted at the top so that you end up with the right overlap, or the boom is raised upwards and downwards so that you can achieve this. The even spray flat fan, this gives a uniform spray across the entire width of the fan. This is the one which is recommended for bend spraying. You target probably the crop rows. And it is uniform. You don't need to, this doesn't require overlapping. This is the uniform volume of spray, so no tapered ends but straight lines. This one is the flat jet nozzle with a filter, which can also be used for applying herbicides. Now we move on to sprayer calibration. Right, in that diagram we are showing the swath width and the nozzle height. There could be a piece of string attached to a weight so that one can maintain the nozzle height. Here we've got instruments for measuring time, the stopwatch, the measuring tape for distance, and the measuring cylinder for measuring the volume of water sprayed. Now, what are the steps, or what is the procedure? The first thing which you need to do is to do the selection of nozzles. Select the correct nozzles for the job. If you are spraying herbicides, don't fit in nozzles suitable for insecticides, or vice versa. You can fill the tank with water and operate the pump to maintain a pressure at 1 to 4 bars. Now you should check the height. Maybe I need to. You should check the height of the nozzle tip from the ground. It should be constant. This is why we may fit in a string and a weight to guide someone who is not experienced, but some experienced workers may manage to maintain the height. Determine the swath, the width of the spray by spraying on the dry surface. You spray the dry surface, you mark straight lines, then you measure that distance. I mean, it's easy to see when you spray it on the ground, especially on a dry surface. Then you walk for a distance of, let's say, 60 meters while pumping the sprayer steadily, and determine the time taken to cover that 60 meters. Do it 3 times and find the mean. Number 6, using the time required to walk a distance of 60 meters, determine the amount of water which is delivered by the knapsack and measure it. So you do it 3 times. For an equivalent time taken to walk 60 meters, measure the volume now of water or output using a measuring cylinder. You also repeat it 3 times so that we find the mean. So this will lead us to this kind of data. Number 1, swath width or width sprayed in meters. Distance traveled during spraying, that will be 60 meters. But I mean, it can vary. If you want to walk 30 meters, it's up to you. Or 100 for that matter. Time taken to walk 60 meters in seconds. Then the amount of liquid sprayed when walking 60 meters in liters. Again, the same things, but we will need now the numbers to fit in to this summary. We can do the calculations. What is the spray rate or the amount of water required to spray 10,000 square meters? It will be 60 times the swath. Will require mean volume in liters. That is right. Then 1 hectare, what will 1 hectare require? That is in black. If 60 times the swath, which is the area which we have sprayed, can require that mean volume of liters which we have measured. What about 1 hectare or 10,000 square meters? So we will use this formula: mean volume in liters times 10,000 square meters, all divided by 60 meters times swath. Now we put in some numbers. Swath width is 1 meter. Distance traveled. Here, of course, we used the 30 meters, the one which was used. Or we could have used the 60 meters. Time taken to walk 30 meters, 30 seconds. If it was 60 meters, it would be 60 seconds. Amount of liquid sprayed, 0.55 liters. Then the amount of liquid applied using that formula, 0.55 times 10,000 divided by 30 meters times 1 meter will give us 183 liters per hectare, which is close to 200 liters per hectare, which is fine. Now, if we're going to put 3 liters of MCPA per hectare in winter wheat, using a knapsack sprayer of 15 liters, how much in terms of MCPA we are going to put into the knapsack sprayer? It will be 3 liters times 15 times 1,000, all divided by 183. Giving us 246 mils. Now we move to the tractor boom sprayer. Last time when we were talking about knapsack sprayer calibration, I said the tractor boom sprayer, it is similar. So this is the tractor boom sprayer with a lot of nozzles. tractor boom sprayer may require a lot of manpower if you want to measure each nozzle. So with a tractor boom sprayer, you mark out the distance. It could be 100 meters. Then you fill the tank with water. You let the driver move the tractor. Probably which covers 100 meters. Now the pump of the sprayer is driven by the power takeoff from the tractor. So you select nozzles which give you the spray output range that you require. Select the number of revs per minute. You ask the driver to set it at 540 revs per minute. And the speed when spraying should be around 5 and 6 kilometers per hour. That is the speed of the tractor. So you will set that speed. Then the tractor with the sprayer filled with water should move for 100 meters in the field to be sprayed. So we should use a stopwatch. We know there could be a speedometer there. So we use the stopwatch to measure the actual time taken by the tractor to cover 100 meters. We repeat it 3 times so that we get an average. Now collect the spray output from nozzles for an equivalent for a period equivalent to the time required to travel 100 meters in the field. So whilst the tractor is now stationary, you ask your driver to rev the tractor and actually start spraying whilst in a stationary position. Then you measure what is coming out of the nozzle. Now, in order to get the swath width, you have to count the number of nozzles. You also need to measure the distance between each nozzle. Then the product of those parameters, if you multiply them, they give you the swath width, which is usually around 6 meters. 30 nozzles are spaced at 50 centimeters intervals. The swath is actually 30 times 50 divided by 100 centimeters. So you can get 15 meters as the swath. Now determination of the spray rate. Spray rate is in liters per hectare. So you have 10,000 multiplied by the spray volume collected for the time taken to travel 100 meters. So you divide this by swath width times 100 meters so that you get the area sprayed, which is in green. So here is an example. We have a number of nozzles, let's say fitted on the boom were 12, and they are 50 centimeters apart. In order to get the swath of the boom, we multiply 12 by 50. The reason why we are dividing by 100 centimeters, we want to convert it to meters. That is the reason. Area to be sprayed is 1 hectare. Distance traveled by the tractor is 100 meters. So the area with one pass to cover 100 meters, it will be 100 meters times 6 meters, which is the swath, and we will get 600 square meters. Sometimes you can just measure the output of one nozzle. Let's say it was 1.5 liters per hectare. You then multiply 1.5 liters times 12. That will give you 18 liters as discharge. And 18 liters will have been sprayed over an area of 600 square meters. So the spray rate, which is in green per hectare, you need this area to be sprayed, which is 10,000 square meters, 1 hectare, times 18, the water which has been delivered, all divided by 600, then you get 300 liters per hectare, which is slightly high, but we can still use this spray rate. So this is the spray rate for the boom sprayer. If your tank capacity was 200 and you want to apply MCPA 3 liters per hectare, the calculation is as follows. It will be 200 times 3 divided by 300. So you will need to take 2 liters of MCPA and put it in the tank and thoroughly mix before spraying. So this is it on the calibration of sprayers, the knapsack sprayer and the tractor boom sprayer. But if you look at it closely, it's more or less the same, except that the tractor boom sprayer has got many nozzles. But we can use the discharge of one nozzle to find out how many, to find out the total discharge of 12 nozzles. So this is it. Let me stop.